Assalamualaikum warahmatullahi wabarakatuh. In this video, we will solve example from practice set 3.5 which are based on tangent secant theorem from the chapter circle. First example, in the given figure, ray PQ touches the circle at point Q. PQ is equal to 12. PR is equal to 8. Find PS and RS. Now here ray PQ is tangent. Ray PQ is tangent since it touches the circle at one point, and PS, ray PS, segment PS is it intersects circle in 2 points. So the line which intersects circle in 2 points, it is called as secant. Is a secant. So by tangent secant theorem, tangent secant theorem tells us that the square of the tangent segment, that is PQ square is equal to PR. We have to start with P, the point of intersection of tangent and secant. So PR into PS. PR into PS. Now substitute the value. PQ is equal to 12. PQ, that is therefore 12 square, is equal to PR is 8 into PS. So 12 square, that is 144, which is equal to 8 into PS. So PS is equal to 144 divided by 8. 8 ones are 8. 8 ones are 8. Carry 6. 8 eights are 64. So PS is equal to 64. PS is equal to 18 units. So PS complete. PS is 18. Here we have to find RS. So between this, PS is equal to PR plus RS. So PS is equal to PR plus RS. P dash R dash S. R is between P and S. So PS is equal to 18. PR equal to 8. PR is 8 plus RS. Therefore, RS is equal to 18. 8 will get subtracted from 18. 18 minus 8, which is equal to 10 units. So RS is equal to 10 units. Question number 2. In the given figure, chord MN and chord RS intersect at point D. RD is equal to 15. DS is equal to 4. DS is 4. MD is equal to 8. Find DN. So by theorem of internal division of chords, two chords intersecting internally. When two chords intersect internally, by theorem, we have to start with point of intersection, that D. So DM into DN is equal to DR into DS. DR into DS. From point of intersection we have to start by theorem of two chords intersecting internally. When they intersect internally, then DM into DN is equal to dr into ds. Now substitute the value. Dm is 8, therefore 8 into dn, we have to find dn, is equal to dr, that is dr is equal to 50 into ds is 4. Therefore dn is equal to 15 into 4 divided by 8. Here 4 ones are 4, 4 twos are 8, 2 ones are 2, 2 sevens are 14, 2 fives are 10. So therefore dn is equal to 7.5 units. Question number 2, second example. We have chord Mn and chord Rs intersect at point D. Rs is equal to Rs complete is equal to 80, MD is equal to 9, Dn is equal to 8. Find ds. So we'll assume here let ds is equal to x. Let ds is equal to x. So this RD, therefore RD is equal to, here RD is equal to 18 minus x. If ds is x, then complete it is Rs is 18, so RD is equal to 18 minus x. Now by theorem of internal division of chords, internal division of two chords, by internal division of two chords, we have to start with dr into ds is equal to dn into dn. So dr into ds is equal to dn into dn. Now dr is equal to 18 minus x into ds is equal to, our assumption that is x is equal to dm. The value of dm is given as 9 and dn is 8. So 9 into 8. Therefore now multiplying this bracket by x into 18 is 18x minus x into x square. 9 sevens are 9 eights are 72. Now taking all these terms on right hand side, so we get the equation, quadratic equation, minus x square will come plus minus 18x plus 72 is equal to 0. A quadratic equation. So we solve this by factorization method. Factors of 72. Such factors of 72, middle term should be 18. So here factors of 72, 8 into 12, 12 into 6, 12 6 are 72, and middle term is negative, so both the factors will be minus 12 and minus 6 is minus 18. Sum of this factor is minus 18 and product minus 12 into minus 6 is plus 72. So we split the middle term, x square minus 12x minus 6x plus 72 is equal to 0. Grouping the terms, two terms together, take common, x is common here, x minus 12 minus 6 common, in bracket x minus 6 came out, here minus into minus will become plus, so minus common, minus 6 common, inside bracket 6 1 the 6 2s are 12 is equal to 0. Therefore x minus 12 in one bracket is common, and in the second bracket x minus 6 is equal to 0. Therefore you will get x minus 12 equal to 0 or x minus 6 is equal to 0. So x is equal to 12 or x is equal to 6. Therefore, here what is asked? ds. Therefore, ds, the value of ds, value of it will have two values. ds is equal to 12 units or ds is equal to, that is 6 units. ds is equal to 12 or 6 units. Question number 3. Question number 3. In the given figure, point O is center of the circle, point B is point of contact, segment O is perpendicular to segment AD, AB is equal to 12, AC is equal to 8, find AD, DC and D. Now in the given figure, here AB, segment AB is equal to, segment AB is a tangent, segment AB is a tangent which intersects circle in one and only one point, and AD is a secant, AD is a secant. Therefore by tangent secant theorem, here square of the tangent segment AB square is equal to AC into AD. AB square is equal to AC, you have to start with the AC into AD. That is AC into AD. Now AB is given as 12. 12 square is equal to AC is 8 into AD. So square of 12, that is 144, is equal to 8 into AD. Therefore, AD is equal to 144 divided by 8. Dividing 144 by 8, 8 ones are 8, 8 ones are 8, 6 carry, 8 are 64, that is 18 units. So length of AD is equal to 18 units. Now second, you have to find here AD is equal to 18 units. Now AD is equal to AC plus CD. That is, we have to find DC. So here 18 minus 8 will get the DC. So between this, AD is equal to AC plus CD. AC plus CD, A dash, C dash, D. Therefore, AD is equal to 18, AC is 8 plus CD. Therefore, CD is equal to 18 minus 8, which is equal to 10 units. That is, DC is equal to 10 units. DC is equal to, DC is 10 units. Now we have to find D. Now here this O is perpendicular to chord, CD is the chord, and perpendicular drawn from the center of circle, it bisects the chord. So D is half of DC. So here next is segment DC is the chord, and O is perpendicular to chord DC. O is perpendicular to chord DC. Therefore, by theorem, perpendicular drawn from center of circle, it bisects the chord into two equal parts. It bisects the chord into two equal parts. So DE is half of DC. D is half of DC. So D equal to 1 upon 2, DC is 10. So 2 1s are 2 5s are 10. So DE is equal to 5 units. Fourth example, in the given figure, PQ is equal to 6, QR is equal to 10, PS is equal to 8, find TS. Find TS. So here, in the given figure, PR is equal to, first, PR is equal to PQ plus QR, that is P dash Q dash R. So PR is equal to PQ 6 plus 10, therefore PR is equal to 6 plus 10 is 16 units. Now here these two chords TP and RP, chord that is PT and chord PR intersect each other at point P externally, at point P externally. Therefore, by theorem of external division of two chords, external divisions of chords. Here, PS, we have to start with the point of intersection of two chords, that is PS into PT, PS into PT is equal to PQ into PR. PQ into PR. Now PS is given, therefore PS is 8 into PT. PS into 8 into PT is equal to PQ 6. PQ is equal to 6 and PR, complete PR is 16, that is 10 plus 6, which is 16 units. So PR is equal to 16. Therefore PT is equal to 6 into 16 divided by 8. 6 1 the 6, 8 1 the 8, 8 2 the 16. Therefore PT is equal to 6 into 2, that is 12. 6 2 the 12 units. So PT is equal to 12 units. We have to find TS. This complete PT is 12 units. So here TP equal to, between this here, TP is equal to TS plus SP, that is P dash H dash P. So TP, that is PT, we got here 12. 12 is equal to TS, we have to find, plus SP is given as 8. SP is equal to 8. Therefore TS is equal to 12. 8 will get subtracted. 12 minus 8. Therefore TS is equal to 4 units. TS is equal to 4 units. Last example. In the given figure, segment EF is the diameter, segment DF is the tangent segment, radius of the circle is R. You have to prove that DE into GE is equal to 4R square. You have to prove that DE into G is equal to 4R square. Now, here DF is the tangent, DF is tangent segment and DE is the secant which intersect the circle in two distinct points. So, and DE is the secant. Therefore, DE is the secant. Therefore, by tangent secant theorem, df square of the tangent segment, df square is equal to dg into de, dg into de, statement number 1. Also we know that this diameter, this EF is the diameter, so EF is equal to 2 times the radius, that is 2r. Statement number 2. Since EF is the diameter, diameter is equal to 2 into r. R is the radius of the circle. Now, here this triangle, in triangle DEF, now in triangle DEF, angle DFE, this angle DFE is the tangent and HF is the radius. So, by tangent theorem, angle DFE is equal to 90 by tangent theorem. By tangent theorem, here this angle is 90 degree. So triangle is a right angle triangle. So whenever right angle triangle, you have to apply Pythagoras theorem. Therefore, by Pythagoras theorem, square of the hypotenuse is d, de square is equal to df square plus df square plus ef square, df square plus ef square. Therefore, we equate this equation to df. Therefore, df square, this df square is equal to de square minus ef square. Now from 1 and 2, from statement number 1, that is df square is equal to dg into de and ef is equal to 2r. So from 1 and 2, this df square is dg into d. df square is dg into d. So we replace the df square as dg into de and d square as it is minus ef. ef is 2r. So we will write here ef is 2r square. So from statement number 1 and 2. Now we simplify. See, dg into de is equal to de square minus 4r square. Now changing the sides, we will take this 4r square minus 4r square on left hand side. It will become plus 4r square is equal to de square. This term will take on right hand side. It will become minus dg into de. Therefore, 4r square is equal to, now this d is common here. D is common. So d common into bracket 1d will remain here minus dg. Now if you refer the figure, de minus dg is equal to g. de minus dg is equal to g. So here we can replace this. 4r square is equal to de into ge. de into g. So here the reason you get the betweenness e dash g dash d. e dash g dash d. Therefore, the that is DE into G is equal to, changing the sides, the required to, that is DE into G is equal to 4R square. Hence we have proved it.